Welcome to the deep dive. So today our mission is to explore this incredibly dense, but honestly absolutely fascinating academic chapter.
Yeah, it really is a dense one.
Right. It was published by IGI Global Scientific Publishing, and it's called A Systems Thinking Perspective on Occupational Health and Safety and Climate Change Interactions.
Quite the title.
It is, yeah. But the goal of today's deep dive is to basically shatter this traditional assumption that climate change just makes outdoor work, a bit sweatier.
Right, because that's what we all tend to think.
Exactly. Usually you and I treat the changing climate like a giant broken thermostat we're all trapped under. We assume, well, if it gets hotter out there, we just need to turn up the air conditioning, hand out some more water bottles, maybe take a longer break in the shade.
Which is a very simple linear cause and effect model.
Yeah, a simple thermostat model. But this paper proves that when you look at the actual human cost, the way our jobs, our physical health, our global economy are all tied to this changing planet, that simple thermostat model completely falls apart.
It really does. And what's so fascinating here is how the source material treats the changing climate. It's not just a series of isolated weather events happening in the background.
Right.
It treats it as a highly active, disruptive participant in our entire socioeconomic ecosystem. So trying to fix one part of this web can inadvertently trigger, like, 3 entirely new, unexpected hazards down the line.
Okay, let's unpack this. Because before we can even talk about the specific dangers workers are facing today, we need to understand how these researchers actually evaluate the problem.
Yeah, the methodology is key here.
Because usually if a machine breaks, you find the snapped gear, you replace it, and the machine works again. But this paper is saying we need to stop looking at the broken gear and start looking at the entire factory floor's wiring.
Exactly. And the researchers actually call that old way of looking at things the linear lens.
The linear lens, right?
Yeah. In traditional occupational safety and health, the workforce is viewed purely as a victim receiving an external stressor. The climate gets hot, the worker gets hot, the employer provides water.
Right, it's a one-way street.
Strictly unidirectional.
Huh.
And the problem is, if policymakers only react to the heat itself, they completely miss how our reaction, like our attempts to adapt or mitigate, create an entirely new set of dangers.
Which brings us to the methodology, because, they didn't just look at a couple of case studies to prove this, did they?
Oh, no. The methodology is arguably the most brilliant part of the entire chapter.
Yeah.
Yeah, they didn't just do a standard literature review. They conducted this massive systematic narrative review, mapping scoping evidence across huge scientific databases.
Like PubMed and Scopus, right?
Exactly.
Yeah.
PubMed, Scopus, the web of science. They essentially fed mountains of data from medical, environmental, and engineering fields into one giant map.
Wow.
Just to trace the ripple effects of climate interventions. And what they built from that data is an analytical framework based on systems thinking and a One Health lens.
Okay, so for anyone listening who isn't steeped in environmental science, what does a One Health lens actually look like in the real world?
Well, think about a logging crew clearing a forest. A linear view just asks, is the chainsaw safe to use?
Right. Do they have eye protection?
Exactly.
Huh.
But a One Health lens recognizes that human health, animal health, and environmental health are fundamentally tethered together.
Oh, I see.
So when that logging crew alters the environment, they disrupt animal habitats, which then pushes tick populations closer to the workers.
Oh, wow. Exposing them to new pathogens.
You got it. You simply cannot isolate the safety of the worker from the ecological balance of the environment they're standing in.
That makes so much sense. So using this massive interconnected map, the research breaks the issue into 3 main syntheses.
Right.
First, the direct climate-driven hazards. Second, the unintended risks of our climate mitigation strategies. And third, the psychosocial and equity impacts.
And looking at the overarching data, there's a massive global imbalance right out of the gate.
Yeah, the paper highlights that low and middle-income countries' LMICs contribute the absolute least to global greenhouse gas emissions.
Right, the absolute least.
Yet they carry the heaviest burden of climate-sensitive, dangerous work, especially in agriculture and the informal sector.
And we connect this to the bigger picture. You have entire regions with weaker regulatory enforcement bearing the brunt of a changing system they didn't fundamentally cause.
Which is just wild to think about.
It is. And this structural imbalance sets the stage for everything we see in the first node of this complex system, which is the direct hits. How the environment is literally breaking down the human body.
And obviously the most direct hit is heat stress. But the paper is quick to point out that it's not just the farm workers and construction crews out in the sun.
No, not at all.
Think about the indoor environments you interact with. The paper specifically calls out bakers, laundry workers, and manufacturing employees in uncooled settings.
Yeah, because as ambient temperatures rise and heat waves stretch from days into weeks, the human body's core ability to eliminate heat gets overwhelmed.
We're talking about a cascade of physiological failures here.
We are. But it goes beyond acute issues like heat stroke. There are these hidden chronic diseases emerging. The source material details a deeply concerning rise in CKDU.
Which is chronic kidney disease of unknown etiology, right?
Exactly.
This really stood out to me because it's not just a passing illness, it's a fundamental change to the organ. How does heat actually cause kidney failure?
Well, it comes down to cellular level damage driven by chronic dehydration. When agricultural laborers work in hot tropical climates day after day without adequate fluid replacement,
Right.
their blood volume actually drops and the blood itself thickens.
Oh man, that sounds awful.
It is. The kidneys are desperate to filter toxins out of this concentrated sludge. Over time, the microscopic filtering units inside the kidney, the nephrons, undergo severe ischemic injury from the lack of blood flow and oxygen.
Wait, so they just scar over?
They scar over, they die. It is irreversible organ damage driven directly by ambient climate conditions.
Irreversible.
Wow. And I imagine heat doesn't just exhaust you physically, it has to make you clumsier too. If your core temperature is spiking, your brain isn't exactly firing on all cylinders.
The data strongly backs that up. Heat significantly impairs cognitive performance, motor skills, and situational awareness.
You drop tools, you trip.
Exactly. You misjudge distances. The researchers analyzed nationwide data from the United States Occupational Safety and Health Administration, OSHA.
And what did they find?
They found that the odds of a worker getting injured increase nonlinearly with the heat. So taking an 80-degree Fahrenheit day as the baseline, when the temperature hits 90 degrees, the odds ratio for an injury is 1.03.
Okay, slightly higher.
But when the temperature climbs to 110 degrees, that ratio jumps to 1.20.
Wow, that is a huge jump. And that's just the heat acting alone. The paper emphasizes a double burden when you factor in the air you're breathing while you're working.
Oh yeah, the air quality component is massive. Because heat actually acts as a catalyst, right? Promoting the faster formation of ground-level ozone, which is a massive respiratory irritant.
Right, and then you add wildfire smoke to that ozone, and the burden on the lungs becomes overwhelming.
Yeah, the source cited an economic analysis showing that in California alone, in the year 2020, at least 282 farm workers were harmed specifically by wildfire smoke.
And cruelly, the risk of injury starts increasing at smoke levels that current regulations actually define as safe.
That's incredibly frustrating. And the shifting environment is also bringing biological hazards to new zip codes.
Yes, the shifting vectors.
With rainfall and temperature patterns changing, vector-borne diseases are expanding their geographic footprint. You have landscaping and forestry workers suddenly dealing with Lyme disease, dengue fever, Zika viruses.
In regions that never had to manage those pathogens before.
Right, and there was also this incredible anecdote in the research regarding extreme weather and marine workers.
All of the desalination failures.
Yes. Deep-sea vessels are facing storms so severe and unprecedented that their onboard desalination systems, the machines that make their drinking water, are completely failing.
Yeah, we are seeing modern marine workers resorting to drinking salt water just to survive a storm.
I mean, it sounds like a 19th century maritime survival novel, but it is happening right now.
It is.
Now, I want to push back a bit on how we normally handle this. We always hear about the holy trinity of outdoor work safety, water, rest, shade.
The classic OSHA guidelines, right?
And the paper notes that when California strictly enforced its heat ordinance, outdoor worker deaths plummeted. But the paper also discusses piece rate workers.
Right, this is a crucial distinction.
These are people paid by the crop picked or the unit finish rather than by the hour. If a worker is paid by the tomato, aren't we basically asking them to choose between their health and their paycheck?
We are.
Yeah.
That financial loophole completely undermines the standard safety advice.
Yeah.
The research shows that piece rate field laborers in Washington state had a 6.2-fold greater chance of experiencing heat-related illness symptoms compared to hourly workers.
6.2-fold. That's insane.
It is. The financial incentive actively drives them to skip those life-saving rest breaks. You can mandate shade all day long, but if sitting in the shade means you don't make rent that month, You're going to keep working until you collapse.
It makes perfect sense. The system itself discourages safety.
And it gets worse when you look at how we try to physically protect these workers. The researchers highlight something called the PPE paradox.
Okay, what is that?
Well, standard personal protective equipment, like an impermeable hazmat suit, is designed to save a worker from chemical exposure.
Right.
But in a warming climate, that heavy, non-breathable suit traps metabolic heat and sweat.
Oh, I see. So the very suit protecting you from a chemical burn is the same suit that might kill you from heat stroke.
Exactly. It's a perfect example of a linear solution failing in a complex system. To fix it, you need systemic adaptations, like developing liquid cooling garments worn underneath the PPE just to manage the trapped heat.
Wow. Okay, so we've established that the climate itself is making the workplace dangerous. But the terrifying irony of this paper is that our desperate scramble to fix the climate is creating an entirely new category of hazards.
Yes, the unintended consequences.
And here's where it gets really interesting. Because the second major synthesis of the research focuses on the green paradox.
It's a great term for it.
It's like we're frantically building lifeboats to escape a sinking ship, but we're using toxic glue to hold the boats together.
That is exactly what's happening. We all tend to assume that because an industry is green and good for the environment, it must naturally be a safe, clean place to work.
Right, you think solar panels, you think clean energy.
But the data tells a very different story. The rapid transition to green technologies is exposing workers to severe, novel hazards.
Let's look at renewable energy. Everyone wants more solar panels, but manufacturing those photovoltaic cells exposes the factory workers to highly toxic chemicals.
Like cadmium telluride.
Or wind power. Installing a massive wind turbine involves working at dizzying heights, often in confined spaces.
While handling dangerous epoxy resins that can cause severe respiratory damage.
It's so counterintuitive.
And the paradox extends directly into the buildings you and I sit in every day. Consider the massive push for highly energy-efficient green buildings.
Okay.
To save energy and reduce the carbon footprint, builders weatherize these structures. You pump in dense insulation, you seal every window gap, you essentially make the building envelope incredibly tight so that no heating or cooling escapes.
Which is fantastic for your electricity bill and the grid.
It is, absolutely.
Yeah.
But by sealing that building so tightly, you dramatically reduce the exchange of fresh indoor and outdoor air.
Oh, so things get trapped inside.
Right. The researchers found that this extreme weatherization traps indoor air contaminants. Think about the volatile organic compounds, or VOCs, off-gassing from office carpets, fresh paint, printer ink.
And suddenly those chemicals have nowhere to go.
Nowhere to go. And even more concerning, a tightly sealed building traps radon, which is a naturally occurring radioactive gas that seeps up from the ground.
Wait, radon, isn't that a leading cause of lung cancer?
It is. So by trying to save energy, we inadvertently trap workers in toxic air.
That's horrifying. And the same exact trap applies to the circular economy, doesn't it?
Yes, e-recycling is a huge issue.
Right, we're all encouraged to recycle our old phones and laptops to reduce waste, but e-recycling exposes the workers manually tearing down those circuit boards to intense levels of lead and mercury.
And it's not just electronics. The paper even notes that large-scale industrial composting creates massive amounts of bioaerosols.
Really? Just from composting?
Yeah, the workers turning that organic soil are developing hypersensitivity pneumonitis, which is a severe and chronic lung disease.
Wow. And we can't forget what the researchers call the safe chemical illusion.
Oh, that case study is wild.
Industry regulators decided to switch to a solvent called 1-bromopropane because it was deemed eco-friendly. It didn't deplete the ozone layer.
Right, it was supposed to be the safe alternative.
But a few years into its use, medical surveillance discovered that this supposedly safe green chemical was causing severe neurological damage in the workers handling it.
So we essentially solved an atmospheric problem by creating a human neurotoxin problem.
Exactly. So how do we actually break this cycle of just trading one disaster for another?
Well, the source material strongly advocates for a methodology called prevention through design, or PTD.
Prevention through design.
Yeah. Instead of treating worker safety as a patch you apply after a green technology is rolled out, PTD demands that safety is engineered directly into the initial blueprint.
The paper uses LEED certification for green buildings as an example of this, right?
Yes, exactly. LEED is now integrating life cycle safety credits.
Okay, how does that work?
So if an architect designs a beautiful green roof covered in solar panels, they must simultaneously design safe, permanent access systems, like integrated anchor points and secure walkways.
Oh, for the future maintenance workers?
Exactly. For the people who will have to clean those panels, you cannot get the green certification unless you prove you've designed a safe physical environment for the human beings maintaining it over the next 30 years.
You literally design out the danger before the concrete is even poured.
Right. You can't just hand a worker a safety harness as an afterthought.
But the physical hazards, the chemicals, the heat, the falls from the roof, that is really only part of the story. The third synthesis in this research shifts away from the physical toxins and focuses on the invisible toll.
Yeah, the mental health aspect.
Because both the climate hazards and our green transition are weighing incredibly heavily on the human psyche.
The psychosocial impacts are profound, actually. And the research divides them into two categories. You have acute trauma, like the PTSD experienced by emergency response workers navigating the chaos of sudden floods and wildfires.
Right, the immediate responders.
But then you have this widespread, slow burn trauma.
Yeah, the paper discusses this concept of ecological grief. Try to imagine you are a multi-generational farmer. You're watching your crops fail due to prolonged multi-year droughts.
It's devastating.
The land your family has worked for a century is just slowly turning to dust. That isn't just a loss of income. It is the withering away of your entire identity.
And the paper links this directly to rising suicide rates among agricultural workers.
It's heartbreaking. And we're seeing unique psychological stressors stratify across different demographics, too. Young workers are reporting intense levels of climate anxiety.
Right, a generalized state of grief and helplessness regarding the future of the ecosystems they have to inherit.
Conversely, workers currently employed in fossil fuel industries are experiencing what the literature calls moral injury.
Which is a really interesting concept.
Yeah, because they realize their daily labor is tied to an industry causing global harm, combined with the severe job insecurity of knowing the global economy is actively trying to transition away from their skill set.
Right. And these psychosocial risks do not fall evenly across the population. They concentrate along pre-existing lines of social inequality.
Which brings us to the intersectional burden of climate change. Vulnerable populations are disproportionately pushed into what occupational health calls 3D jobs.
Dirty, dangerous, and difficult.
Exactly. The source material focuses heavily on migrant workers in this regard. They're facing extreme heat in the fields, but they also navigate severe linguistic barriers, substandard housing, restricted access to healthcare.
The paper also highlights pregnant workers who face significantly elevated risks of adverse outcomes, including stillbirth from prolonged exposure to extreme heat.
And this is where the systems thinking perspective zooms all the way out to the global supply chain. The researchers employ an environmental justice framework to document an economic reality known in the literature as ecologically unequal exchange.
Right, it's a critical concept. Let's walk through the economic logic of that because it's vital to understanding the whole picture.
Okay.
Extracting the raw materials for clean energy, like mining cobalt for electric vehicle batteries, involves moving massive amounts of earth and dealing with highly toxic runoff.
Sure.
If a high-income nation tries to do that within its own borders, strict environmental and labor regulations make the process astronomically expensive.
So the market pushes that hazardous labor down the supply chain. Global efforts to shift to low-carbon technologies in high-income countries rely heavily on resource extraction and e-waste disposal that are subcontracted out to low- and middle-income countries.
Exactly.
So if rich countries are just exporting the toxic, dirty work of clean energy to vulnerable populations, are we actually solving the global problem or just moving the pollution out of our own backyards?
This raises an important question, and it is a structural mechanism the academic literature is deeply critical of. The studies point out that high-income regions get to transition to sustainable, pristine models, while the hazardous labor required to build those solar panels and dispose of those batteries is shifted to areas where labor protections are the least stringent.
Out of sight, out of mind.
Basically. According to this environmental justice framework in the text, true adaptation cannot rely on telling an unregulated worker to simply be more resilient.
Right.
It requires procedural justice across the entire global supply chain.
So what does this all mean? We started with the idea of a broken thermostat, only to realize we're actually navigating the incredibly complex, often toxic wiring of our global economy. How does the source material suggest we actually move forward?
The overarching conclusion is the absolute necessity of a just transition.
A just transition.
Yes, we cannot achieve true environmental sustainability at the expense of worker health, safety, and equity. If a green job is a dangerous job, it is not a sustainable solution.
Makes sense.
The researchers advocate for transdisciplinary monitoring, meaning we must use foresight techniques to anticipate the human hazards of new technologies, like hydrogen power or advanced nanotechnology, before they are deployed at scale.
It requires a fundamental shift in how we value human labor in the face of a changing planet.
It absolutely does.
Which leaves us with one final unaddressed thought for you to ponder. As extreme weather becomes the new unpredictable norm, the very definition of what constitutes a safe working environment might have to change daily, maybe even hourly, based on your weather app.
Yeah.
If the planet itself is increasingly becoming an unpredictable, hazardous workplace, will future labor rights have to include the fundamental right to simply not work when the Earth is deemed too sick to step outside?
It's a paradigm-shifting idea. We are entirely used to assessing the structural safety of a building or machine.
Right.
But how do you assess the safety of the sky above you when the baseline is constantly shifting?
It makes you look at that broken thermostat completely differently. Thank you so much for joining us on this deep dive. Keep questioning the systems around you, and we'll see you next time.